All right, in this section, section 12, or chapter 12, section 2, we're going to talk about matrix multiplication. And our learning objective is to multiply matrices using scalar and matrix multiplication. So a real number factor is called a scalar. And when you multiply a matrix by a scalar, it's called scalar multiplication. And the cool part about it is that when you have a matrix and you multiply it by a scalar, you multiply every element in your matrix by that scalar amount. So we are going to use matrices A and B from problem 1 and to find out what 3A minus 2B is. So we are going to take this entire A matrix and multiply by 3, this entire B matrix and multiply it by 2, and then subtract those results. So 3A is 2 times 3 is 6, 8 times 3 is 18. Negative 3 times 3 is 9. Negative 1 times 3 is negative 3. 5 times 3 is 15. And 2 times 3 is 6. So that's 3A minus. And then we want 2B. So I'm going to double everything in here. Negative 1 times 2 is negative 2. 2 times 0 is 0. 2 times 5 is 10. 0 times 2 is 0. 3 times 0 is 6. Negative 2 times 2 is negative 4. All right, now each of these elements I'm going to subtract. So I got 6 minus negative 2, 18 minus 0, negative 9 minus 10, negative 3 minus 0, 15 minus 6, and 6 minus negative 4. When I do all that, my resultant is 6 plus 2 is 8. 18 minus 0 is 18. Negative 9 minus 10 is negative 19. Negative 3 minus 0 is negative 3. 15 minus 6 is 9. 6 plus 4 is 10, and that is the answer. All right, so let's look at some properties here of scalar multiplication. If A and B are M by N matrices, C and D are scalars, and O is the zero matrix, then here are some properties. When you multiply by a scalar, your matrix stays the same size. It's called the closure property. When you have two scalars and you're multiplying it by a matrix, you can first multiply it by one scalar and then multiply it by the second. When you have two matrices added together and you're multiplying both by the scalar, it's the same as the first multiplied by the scalar plus the second multiplied by the scalar. If you have two scalars adding together and they're both being multiplied by the matrices, it's the same as each individual one multiplied by its scalar and then added together. So those are the associative property multiplication, the distributive properties. The multiplicative identity property is 1 times the matrix is the matrix. Same with the multiplicative properties of 0. When I multiply the matrix by 0, I get the 0 matrices. And if I try to multiply the 0 matrix by a scalar, I will get the 0. All right, so let's look at our, we have 3 times a matrix minus 2 times a matrix with elements is equal to 17, negative 13, 7, and 0 matrix. we want to know what the solution is. So we essentially want to find this matrix X. So the first thing that we are going to do is we're going to multiply through the 2. So 3 times x minus, and then everything in here, I'm going to multiply by 2. 14 and 0. And it equals this matrix here. All right, so to get this X matrix by itself, I'm going to add this doubled up matrix. And it's going to, this is a minus. If I add it to both sides, then I will 0. So then I have 3x equals, I'm going to add each of these elements together. 17 plus negative 2 is 15. Negative 13 plus 10 is negative 3. Negative 7 plus 14 is 7. And 0 plus 0 is 0. All right, so the next thing I'm going to do is divide by 3. But another way to write that, because dividing by 3 is kind of an awkward way to write that in matrix. So I'm going to multiply by 1/3. So 1/3 times 3 is our x term. And then I just will give everything in here a divided by 3. So I get 5, negative 1. 7/3 is 2 1/3, and 0 divided by 3 is 0. Yay! So that's what x equals. All right, matrix multiplication gets a little bit more complicated than just straight up multiplication. So watch, and what I do is I just keep this handy. So matrix A times matrix B is, we want to get the very first term, 12 and 21. Okay, so to get this term, I take my first term in A and my first term in B and multiply it together, and then I go to the right in A and then I go down in B. So plus whatever the product of A, the second on the top row, times the second in the first column. Then to get this term here, I go this guy and the first guy plus, so the first term on the bottom and the first row on top, plus second guy here and the first guy on the column here. Then to get this guy, I take my first term and my first guy from the second row, or from the second column, and then my top guy here, and then multiplied by this guy over here. Then last but not least, to get this guy here, I go this one and this one plus this guy and this guy. When I do all that, the resulting matrix is the product of those two. Delete all this so that you guys can read it. All right, so let's try that. So we are going to find what A times B is. So we're going to go 2, -1, 3, 4 times -3, 1, 0, 2. So I'm just going to follow this little instruction right here. So to find my first guy here, I'm going to take my first terms, 2 times -3 plus -1 times 0. To get this guy here, I'm going to take my first term, which is 2, and multiply it by the first in the second column. And then I'm going to take my -1 and multiply it by the 2. All right, so to go bottom, I go bottom left, that's 3 times my first guy here, which is -3, plus my guy on the second row, which is a 4, and times this guy here, which is 0. So then I'm going to have the 3 and the 4 again, but instead of the ones in this row, I'm going to have the ones in this row. So I'm going to go 1 and 2 times 1 times 2. All right, so when we do all that out, I have 2 times -3 is -6 plus 0. That's -6. I get 2 times 1 is 2, plus -1 times 2 is -2. That's 0. And then 3 times -3 is -9, plus 0 is still -9. 3 times 1 is 3, plus 4 times 2 is 8, 3 plus 8 is 11. So the product of A times B is -6, 0, -9, and 11. So just for practice, we're going to try that one more time. But instead of the first one, we're going to have our B go first and our A go second. All right, so in this case, I'm going to have -3 times, so it was 2 times -3, now it's going to be -3 times 2. Plus, it was -1 times 0, but now it's going to be -3 times 3. And then this one is going to be -3, so here I had 2, but instead I'm going to have -3 times a 1. In this case, it's -1. And it is 1. All right, so I have to change this up. This is 1 right here. Oh, 1, because it goes -3 and 1, and then times 2 and times 3. Boom. So So negative 3 times negative 1 and 1 times 4. Boop, boop. Okay. So now bottom gives us 0 and 2. So 0 times this 2 plus 2 times 3. And then last but not least, we get 0 and 2, but we're going to go times negative 1 and times 4. Okay, so when we do all that out, this gives me negative 6 plus 3, which is negative 3. And this is negative 3 times negative 1 is 3. Plus 1 times 4 is 4. That's 7. This is 0 plus 6, 6. And 0 plus 8 is 8. So as you can see, matrix multiplication is not commutative. We did it, A times B was not equal to B times A. So when we switched it around, it didn't equal each other. All right, so let's look at when we have a word problem. There are 3 ways to score in a basketball game: 3-point field goals, 2-point field goals, and 1-point free throws. In 1994, a high school player scored 32 2-point field goals, 36 2-point field goals, and 28 free throws. We have to, for the record, show that there were no 3 points. In 2006, a high school scored 7 3-point field goals, 21 2-point field goals, and 18 free throws. Using matrix multiplication, how many points did each player score? So your first matrix is this. And we want to make sure we multiply by 3 points is 3, 2 points is 2, and 1 point is 1. So we're going to go ahead and do this multiplication. So, as a result, this is a 3 by 2 matrix, and we're multiplying it. Actually, it's the opposite. Okay, so this is a 2 by 3 matrix, and this guy right here is a 3 by 1 matrix. And when we multiply them together, we should get this one cancels out, and we should get a 2 by 1 matrix. So it's going to go 0 times 3, boom. 36 times 2, boom. 28 times 1, boom. And then we do the same, drop down and do the same thing with this guy. 7, okay. 7 times 3 plus 21 times 2 plus 18 times 1. When we add those all together, we get 100 points for our 1994 player and 81 for our 2006 player. All right, so let's make it official. The dimensions of a product matrix. So if I have an M by N matrix and B is an N by P matrix, then the product is M by P. So in this scenario, I have, if you look, what I try to look for is that when you put them side by side, the ones that sit right next to each other have to be equal. And the result is what you get when you go first and last. So if I have a 3 by 2 and a 2 by 4, then the 2's will drop and my result will be 3 by 4 matrix. So we want to, in number 5, we're going to determine if the following products exist. This is a 2 by 2. This is a 1 by 2. This is a 2 by 3. So we're going to determine if each of these do they have products? And they have products if their inside items match. So A times B is a 2 by 2, and B is a 1 by 2. These guys do not match, so this is a no. B times A is 1 by 2 for B and 2 by 2 for A. These match, so this is a yes. A times C is a 2 by 2. C is a 2 by 3. The middles match, so it's a yes. Flip it. 2 by 3 and a 2 by 2. These do not match, so it's a no. And last but not least, a 1 by 2 for B and a 2 by 3 for C. Middles match, so this is a yes. So if the middle number matches, you can multiply it. If it doesn't, you cannot multiply it. So let's look at some properties for matrix multiplication. If A, B, and C are n by n matrices, and O is the n by n zero matrix, then all these things are true. A times B is an n by n matrix. It doesn't matter, because they're all the same size, which order I multiply it in. That's the associative property of multiplication. It doesn't matter when it'll distribute out. One matrix will distribute out to the other two matrices if we're adding. As well as whether it's forward or backward. Anything times the zero matrix is going to give you the zero matrix. That's the multiplicative property of 0. And that's it for this lesson.